Industry 4 needs new skills, new technologies, and tools. Above everything else, a problem solving mind. Welcome to Blackbuck Executive Education. This video covers Introduction to Artificial Intelligence. Learning AI is like reprogramming your mind. We will help you do that with ease. Artificial intelligence is all set to change the world. Chances are good that you can help the world change. Objective of this learning path is to teach you very basics of artificial intelligence. The course is aimed at a very large audience, so we try to make sense to anyone in technology field, but by keeping the jargon low. Also, AI is a beautiful stream in the field of computer science that it can keep endless possibilities in front of you. So the objective is very importantly to excite you about the AI. The structure will involve Introduction to Artificial Intelligence. As part of this, we will be discussing foundations of artificial intelligence, including the philosophy, basic characteristics, and principles of AI. Opportunity landscape. What sectors are looking at AI? How is the investment landscape? Leverage technology benefits. We will be seeing what opportunities are businesses looking at and what's in it for you. Transform business with technology. The benefits that the industry wants to achieve using AI, and currently the features that businesses are implementing and the trends. Deep dive into details and discover technology. We will also discuss use cases related to multiple industries. This section will involve Introduction to AI, which will cover philosophy and principles of artificial intelligence. It covers the foundational aspects of artificial intelligence. You can hardly avoid encountering mentions of AI today. You see AI in the movies, in books, in the news, and online. AI is part of robots, self driving cars, drones, medical systems, online shopping sites, and all sorts of other technologies that affect your daily life in so many ways. But one thing is for sure, workers of the future will spend more time on activities that machines are less capable of. They will spend less time on predictable physical activities and on collecting and processing data where machines already exceed human performance. The skills and capabilities required will also shift to more advanced cognitive capabilities such as solutioning, logical reasoning, and creativity. Basic characteristics an AI system might have. I'm saying might because not all need to be present in one system. Learning, having the ability to obtain and process new information. Reasoning, being able to manipulate information in various ways. Understanding, considering the result of information manipulation. Grasping truths, determining the validity of the manipulated information. Seeing relationships, defining how validated data interacts with other data. Considering meanings, separating fact from belief. In summary, there are four principles that define an AI. 1. Acting humanly. A basic test to let you know whether a computer is a human or not is called Turing test. Imagine a man in a locked room. This man gives you answers of all the questions you ask. When you start speaking to this man from outside of the room, if you have no doubt whether the person inside is a human or a computer, then the system is successfully an AI system. All our online bots are supposed to behave like that, but you very well know how they behave. A system to pass Turing test is difficult. To pass such a test, you will have to employ technologies such as natural language processing, knowledge representation, automated reasoning, and machine learning. We have to, however, remember that the idea of AI is to achieve a defined goal rather than mimicking humans completely. For example, the Wright brothers didn't succeed in creating an airplane by precisely copying the flight of birds. Rather, the birds provided ideas that led to aerodynamics that eventually led to human flight. The goal is to fly. Both birds and humans achieve this goal, but they use different approaches. 2. Thinking humanly. When a computer thinks as a human, it performs tasks that require intelligence from a human to succeed, such as driving a car. To determine whether a program thinks like a human, you must have some method of determining how humans think, which the cognitive modeling approach defines. This model relies on three techniques: introspection, detecting and documenting the techniques used to achieve goals by monitoring one's own thought process; psychological testing, observing a person's behavior and adding it to a database of similar behaviors from other persons given a similar set of circumstances, goals, resources, and environmental conditions, among other things; brain imaging, monitoring brain activity directly through various mechanical means, such as MRI. After creating a model, you can write a program that simulates the model. Given the amount of variability among human thought processes and the difficulty of accurately representing these thought processes as part of a program, the results are experimental at best. This category of thinking humanly is often used in psychology and other fields in which modeling the human thought process to create realistic simulations is essential. 3. Thinking rationally. Studying how humans think using some standard enables the creation of guidelines that describe typical human behaviors. A person is considered rational when following these behaviors within certain levels of deviation. A computer that thinks rationally relies on the recorded human behaviors to create a guide as to how to interact with an environment based on the data at hand. The goal of this approach is to solve problems logically when possible. Solving of a problem in principle is often different from solving it in practice, but you still need a starting point. Acting rationally. Studying how humans act in given situations under specific constraints enables you to determine which techniques are both efficient and effective. A computer that acts rationally relies on the recorded actions to interact with an environment based on conditions, environmental factors, and existing data. Based on the above four principles, an AI engineer's aim is to move from machines that do to machines that think and act. Do you want to make one? With the basic foundation of principles and philosophy related to AI, we move on to the next section. In this section, let us examine the opportunity landscape, the investments, technology benefits, and how industry leaders are transforming business with technology. Tech giants and digital native companies such as Amazon, Apple, Baidu, and Google are investing billions of dollars in various AI technologies. They're using powerful hardware, increasingly sophisticated algorithmic models, and a vast and fast-growing inventory of data. The estimate of spend is amounted anywhere between $18 billion to $27 billion. Amazon is working on robotics and speech recognition, Salesforce on virtual agents and machine learning. BMW, Tesla, and Toyota are among the manufacturers making sizable investments in robotics and machine learning to use in driverless cars. Toyota, for example, set aside $1 billion to establish a new research institute devoted to AI for robotics and driverless cars. Industrial giants such as ABB, Bosch, GE, and Siemens also are investing internally, often in machine learning and robotics, seeking to develop specific technologies related to their core businesses. IBM has pledged to invest $3 billion dollars for its Watson cognitive computing service, a force in the Internet of Things. Baidu has invested $1.5 billion dollars in AI research over the last 2.5 years. The pool of true experts in the field is small and the demand is high. Have a look at the demand in various sectors in AI adoption. The leading sectors include financial services, high-tech and telecommunications, transportation, automotive and energy, healthcare and energy. What benefits are the businesses expecting out of AI? Businesses plan to use AI for a number of activities, ranging from being cost effective to having a competitive advantage, such as automate routine processes and tasks to save time and money, collect and analyze data from smart sensors, or using machine learning algorithms to categorize work, automatically route service requests, etc. Increase productivity and operational efficiencies. For example, AI power image recognition tools to monitor and optimize your infrastructure, plan transport routes, etc. Automate production line by integrating industrial robots into your workflow and teaching them to perform labor-intensive or mundane tasks. Use insights to predict customer preferences and offer them better. Predict performance and behavior to analyze patterns of online behavior. For example, serve tailored product offers, detect credit card frauds, or target appropriate adverts. Make faster business decisions based on outputs from cognitive technologies. Avoid human error, provided that smart systems are set up properly. Some AI you already might be seeing, or you might be working on developing one soon. Spam filters, smart email categorization, voice to text features, smart personal assistants such as Siri, Cortana, and Google Now, automated responders and online customer support, smart devices that adjust according to behavior, automated insights, especially for data driven industries, example financial services or e commerce, smart searches and relevance features, product recommendations and purchase predictions, fraud detection and prevention for online transactions, dynamic price optimization based on machine learning, recommendations and content curation, personalization of news feeds, pattern and image recognition, language recognition to digest unstructured data from customers and sales prospects, ad targeting and optimized real time bidding, social semantics and sentiment analysis, automated web design, predictive customer service. In the later parts of this video, we will be discussing applications by vertical. You will be able to look into your interested domains related to your work. Trends that artificial intelligence is setting up. In about 60% of occupations, at least one third of the constituent activities could be automated, implying substantial workplace transformations and changes for all workers. The workforce needs to change its rules. More and more jobs will be shifting towards high cognitive abilities. Our old job descriptions, engineer, product manager, designer, are breaking down. For example, if you look at the self driving cars, you don't need a wireframe for a self driving car. That just doesn't make as much sense. So, we are inventing brand new processes and workflows for the AI era as well. More investments will be seen in setting up infrastructure for AI, increasing machine person ratios, and upgrading technology infrastructure, machine and deep learning will improve. The biggest use will be to find fraud and crime and recognition recommendation engines. Example algorithms to detect financial crimes such as credit card frauds, synthetic identity theft, AML, and others. AI will integrate more natural language processing to converse in human understandable terms, especially for consumer facing applications. Deep learning will reach larger areas of user. Millions of data scientists will adopt and rebuild machine learning pipelines. AI research and development is happening in a number of fields that try to mimic human activities and behavior. In this section, we will be learning various subfields of AI that are making remarkable progress. Let's get into knowing more about AI, its branches, and what functions AI will achieve using these branches. The goal of AI is to create systems that can function intelligently and independently. There are two broad categories that AI can fall into: symbolic and machine learning. Symbolic learning believes in developing an intelligent system based on rules and knowledge and whose actions were interpretable, while non-symbolic approach strives to build a computational system inspired by the human brain. For a clear understanding, remember the man in the room for Turing test. Suppose the man in his room has loads of data, information, videos, and so on. You ask him a question, he refers to all that he has and answers. It is symbolic branch of AI. It is like Google algorithms. Suppose the man has learned from all he has seen from his childhood and hence has intelligence by himself. It is called machine learning. Machine learning is where you expect the machine to learn by itself and adjust with changes. A programmer will define learning mechanisms to the system through algorithms. Humans can speak and listen to communicate through language. This is the field of speech recognition. Much of speech recognition is statistically based, hence it's called statistical learning. Humans can write and read text in a language. This is the field of NLP or natural language processing. Both these functions use statistics and related programming, so they come under a subset called statistical learning. As we talked about, when system searches from the information fed into it, it is called symbolic learning. Under symbolic learning, we have two branches: computer vision and robotics. Humans can see with their eyes and process what they see. This is the field of computer vision. Computer vision falls under the symbolic way for computers to process information. Interestingly, it also falls as a technique under machine learning. Humans can understand their environment and move around fluidly. This is the field of robotics. Another important term you have to understand is image processing. We have already seen an example of the same, the London CCTV cameras. Humans recognize the scene around them through their eyes, which creates images of the world. This field of image processing, which even though is not directly related to AI, is required for computer vision. Humans have the ability to see patterns such as grouping of like objects. This is the field of pattern recognition. Machines are even better at pattern recognition because they can use more data and dimensions of data. This is the field of machine learning. Pattern recognition is a machine learning activity. It is a part of intelligence building. Now let's talk about the human brain. The human brain is a network of neurons, and we use these to learn things. If we can replicate the structure and the function of the human brain, we might be able to get cognitive capabilities in machines. This thought process is again a field of machine learning. This is the field of neural networks. If these networks are more complex and deeper, and we use those to learn complex things, that is the field of deep learning. There are different types of deep learning and machines, which are essentially different techniques to replicate what the human brain does. If we get the network to scan images from left to right, top to bottom, it's a convolution neural network. A CNN is used to recognize objects in a scene. This is how computer vision, which fits in an object recognition, is accomplished through AI. The best example where CNN is used is driverless cars. I need to make a special mention of data here. Data comes from a number of sources. The most important data source is from information entered by humans at some point. Even when a system collects shopping site data automatically, humans initially enter the information. Data is also connected from sensors, and these sensors can take almost any form. For example, many organizations base physical data collection, such as the number of people viewing an object in a window, on cell phone detection. Facial recognition software could potentially detect repeat customers. All the data that comes from different places in different forms, including images, need to be processed extensively. There will be missing data, misalignments, bias, etc. There are methods to train data. When you train data using algorithms that also contain the answer, then it's called supervised learning. For example, when you train a machine to recognize your friends by name, you will need to identify them for the computer if you train an algorithm with data. Where you want the machine to figure out the patterns, then it's unsupervised learning. For example, you might want to feed the data about celestial objects in the universe and expect the machine to come up with patterns in that data by itself. There are a number of algorithms that you have to get familiar with for supervised and unsupervised. What skills are needed for developing an AI system and its variants? Machine learning, deep learning, natural language processing, predictive analytics, and multiple neural networks. Math. You need to know data and how to use math to use the data. Algebra, statistics, and calculus are all important for algorithms. Software developers can't just take a Python library and apply it to a problem. Neural. You need to understand human thought process for NLP, context, intent, and how to link entities. Deeper insight into the human thought process. Data. Understanding of a bit of data modeling, big data, and expertise in one or more programming languages like Python or R will be good start for developers who are trying to get into AI. Be able and willing to look at the data, understand it, be suspicious of it, have empathy for it, and be able to graph it to achieve a level of understanding. A lot of ML and AI algorithms. You might need to know image processing, understand open source tools. Backend developers need to know machine learning and a lot of open source technology around AI, especially R and Python languages. Front-end developers need to learn about bots and conversational flows. Most importantly, you need to know your domain so that you derive meaningful outcomes. We will be delving deep into various aspects of AI. We will be discussing in detail each of the subfields of AI. We will also discuss prerequisites for the course, tools, frameworks, their features, pros and cons. We will also discuss use cases related to multiple industries. It is very important to know some key terms when it comes to AI. We will look into very few of the basic terms that are generally used in AI. This section discusses agents, intelligent agents, problem solving, and knowledge representation. We will be then discussing in detail about few of the important branches of AI, which we have already discussed. Finally, we will be discussing various tools and techniques required for developing an AI system. Let's now look at the key terminology used when you're developing an AI system. Intelligent agents. A human agent has eyes, ears, and other organs for sensors, and hands, legs, vocal tract, and so on for actuators. These sensory organs are agents to the mind. Similarly, AI systems have agents and environment. A robotic agent might have cameras and infrared range finders for sensors. Just like our sensors give us input for our perception, We use the term percept to refer to the agent's perceptual inputs. An agent can have one percept or a percept sequence that includes complete history of everything the agent has ever perceived. Once the input is given into the system with the help of sensors, if then else clauses will work and output is sent out through actuators like motors in the form of act. A task environment specification includes the performance measure, the external environment, the actuators, and the sensors. In designing an agent, the first step must always be to specify the task environment as fully as possible. Task environments vary along several significant dimensions. They can be fully or partially observable, single agent or multi agent, deterministic or stochastic, episodic or sequential, static or dynamic, discrete or continuous, and known or unknown. Simple reflex agents takes action based on only the current environment situation. It maps the current percept into proper action, ignoring the history of percepts. The mapping process could be simply a table-based or by any rule-based matching algorithm. Example of this class is a robotic vacuum cleaner that works in an infinite loop where it checks the state of a current location, clean or dirty, and accordingly it decides whether to suck or continue moving. Model-based reflex agents needs memory for storing the percept history. It uses the percept history to help reveal the current unobservable aspects of the environment. Example of this class is the self-steering mobile vision, where it's necessary to check the percept history to fully understand how the world is evolving. Say for example, yesterday there is no cow on the road, today there is. Goal-based reflex agents. This kind of agent has a goal and has a strategy to reach that goal. All actions are based on its goal, and from a set of possible actions, it selects the one that improves the progress towards the goal. Example of this class is any searching robos that has initial location and want to reach a destination. Utility-based reflex agents, like the goal-based reflex agent, but with a measure of how much happy an action would make me rather than the goal-based binary feedback, happy and happy. This kind of agent provides the best solution. An example is the route recommendation system, which solves for the best route to reach a destination. Learning agents. Just like human, AI agents are supposed to improve their performance through learning. The essential component of autonomy, this agent is capable of learning from experience. It has the capability of automatic information acquisition and integration into the system. Any agent designed to be successful in an uncertain environment is considered to be learning agent. Problem solving. Suppose a person has to travel from city A to city B. Which road should he take is a problem. We are not delving into details, but every problem that AI has to solve should qualify by certain criteria. How will you decide which is the best path? In case you do not know the best route, but you have number of paths, which one will you take? To start with, you should be able to define a path cost function that assigns a numeric cost to each path. The problem-solving agent chooses a cost function that reflects its own performance measure. For the agent trying to get to a place from another place, time is of the essence, so the cost of a path might be its length in kilometers, or you might add some weights to the path based on your understanding of the climatic conditions, crime, and other risk factors involved. AI foundations will expect you to understand problem-solving concepts. Examples of the usage of these algorithms are the traveling salesperson problem. TSP is a touring problem in which each city traveling must be visited exactly once. The aim is to find the shortest tour. The problem is known to be NP hard, but an enormous amount of effort has been expended to improve the capabilities of TSP algorithm. The traveling salesperson problem is a touring problem in which each city traveling must be visited exactly once. The aim is to find the shortest tour. The problem is known to be NP hard, but an enormous amount of effort has been expended to improve the capabilities of TSP algorithm. VLSI layout problem requires positioning millions of components and connections on a chip to minimize area, minimize circuit delays, minimize stray capacitances, and maximize manufacturing yield. The layout problem comes after the logical design phase and is usually split into two parts: cell layout and channel routing. In cell layout, the primitive components of the circuit are grouped into cells, each of which performs some recognized function. Each cell has a fixed footprint, size, and shape, and requires a certain number of connections to each of the other cells. The aim is to place the cells on the chip so that they do not overlap and so that there is room for the connecting wires to be placed between the cells. Channel routing finds a specific route for each wire through the gaps between the cells. Knowledge representation. Now that we know AI is based on knowledge fed into the system, it is very important to study how knowledge is represented in the system. Google stores knowledge so efficiently that it makes agents pick links in nanoseconds. Knowledge representation is a sub-area of AI concerned with understanding, designing, and implementing ways of representing information in computer so that programs can use this information for different purposes. There are four types of knowledge representation: logical representation, production rules, semantic network, frame representation. In detailed courses, we will get into details of how knowledge is represented in these forms. Let us get into details of the different branches of AI that we already had an overview. Let us start with computer vision. For humans, perception appears to be an effortless activity. You make perceptions without applying conscious knowledge. But in case of computers, it requires a significant amount of sophisticated computation. The goal of vision is to extract information needed for tasks such as manipulation, navigation, and object recognition. The process of image formation is understood through its geometric and physical aspects. Given a description of a three-dimensional scene, we can easily produce a picture of it from some arbitrary camera position, the graphics problem. Inverting the process by going from some description of the scene is more difficult. And that is what we have to exactly do to a computer in order to help computer recognize an object. There are various cues in the image that enable one to obtain three-dimensional information about the scene: motion, texture, shading, edges, contour analysis, and many other attributes. Object recognition in its full generality is a very hard problem. I would like to remind you that computer vision falls under both kinds of AI. To an algorithm, the image of a flower looks like just a massive array of integer values which represent intensities across the color spectrum. There is no context here, just a massive pile of. It turns out that the context is the crux of getting algorithms to understand image content in the same way that the human brain does, and to make this work. We use an algorithm very similar to how the human brain operates using machine learning. CNN. Sometimes we ourselves have problem in identifying things. Let's take a look at these images of sheep, dogs, and mops, where it's even pretty difficult for us to identify and differentiate which is what. With the machine learning model, however, if we can take a bunch of images of these sheep, dogs, and mops, and as long as we feed it enough data, it will eventually be able to properly tell the difference between the two, where we cannot. Computer vision is taking an increasingly complex challenges and is seeing accuracy more than humans performing the same image recognition tasks. The specific type of neural network that accomplishes this is called convolutional neural network, CNN. In neural networks, convolutional neural networks, CNN, is one of the most important categories that does image processing or image recognition, image classification, objects detection, recognition of faces, etc. CNN image classification takes an input image, processes it, and classifies it under categories already fed into it, like dog, flower, or cat. Computers see an input image as array of pixels, and it depends on the image resolution. Based on the image resolution, it will see height, width, depth. What you are now seeing is a neural network that recognizes a number. Say our training data for the network will consist of many 28 by 28 pixels of scanned written digits, and so the input layer contains 784 neurons. You don't see 784 inputs on the left side for simplicity of the image sake. Here is most simple way of representing a neural network. The leftmost layer in this network is called the input layer, and the neurons within the layer are called input neurons. The rightmost or output layer contains the output neurons, or as in this case, a single output neuron. The middle layer is called a hidden layer, since the neurons in this layer are neither inputs nor outputs. The design of the input and output layers in a network is often straightforward. For example, suppose we are trying to determine whether a handwritten image depicts a 9 or not. A natural way to design the network is to encode the intensities of the image pixels into the input neurons. If the image is a 64 by 64 grayscale image, then we'd have 64 by 64, which is 4096 input neurons. The input pixels are grayscale with a value of 0.00.0 representing white, a value of 1.01.0 representing black, and in between values representing gradually darkening shades of gray. The second layer of the network is the hidden layer. The example shown illustrates a small hidden layer containing just n is equal to 15 neurons. Depending on the curve the input has and the position where the curve is or line is, the network will choose that route of the hidden layer. For example, 9 should have a curve on the top, curve in the middle, and line at the bottom. In a realistic NN, there will be multiple middle or hidden layers. The output layer of the network contains 10 neurons. If the first neuron fires, that is, has an output of about 1, then that will indicate that the network thinks the digit is a 0. If the second neuron fires, then that will indicate that the network thinks the digit is a 1, and so on. A little more precisely, we number the output neurons from 00 through 99 and figure out which neuron has the highest activation value. It is still a great deal to recognize when the same dog can be pictured in number of dimensions, colors, shadows, and so on. RNN or recurring neural network. When we move to video, things get more difficult since the item we are identifying might change over time, or more likely there's context between the video frames that's highly important to labeling. For example, if there's a picture of a half full cardboard box, we do not know if we have to label it as packing a box or unpacking a box. We only can do depending on the frames before and after it. This is where CNNs come up, lacking features of the visual data in an image, but can't handle time features, how a frame is related to the one before it. To address this issue, we have to take the output of our CNN and feed it into another model, which can handle the temporal nature of our videos. This type of model is called a recurrent neural network or RNN. While a CNN treats groups of pixels independently, an RNN can retain information about what it's already processed and use that in its decision making. RNNs can handle many types of input and alpha data. A recurrent neural network basically unfolds over time. It is used for sequential inputs where the time factor is the main differentiating factor between the elements of the sequence. For example, here is a recurrent neural network used for language modeling that has been unfolded over time. At each time step, in addition to the user input at that time step, it also accepts the output of the hidden layer that was computed at the very previous time step. The next function we will be discussing is automated speech recognition. An automated speech recognition system is one which accurately translates spoken utterances into text. Text can be either in forms of words, or it can be a word sequence, or it can be in terms of syllables, or it can be any subword units or phones, or even characters. When you are listening to a YouTube video, an ASR engine is running and producing the corresponding transcripts for the speech, the audio, and the video clips. Siri, Cortana, Google Voice, and all of their front ends are ASR engines. ASR can be challenging because of various reasons. It's difficult because there are several sources of variability. So one is just your style of speech and sentence formation of different cultures. Another, of course, is environment. If you're speaking in very noisy conditions, or if your room acoustics are very challenging, or you are speaking in the presence of interfering speakers. If you're talking and there's background noise, if it is a vehicle noise or something, it can be easily isolated. But there are actually people talking in the background. That's really hard for ASR systems to pick out the voice in the foreground and work on it. Then, of course, speaker characteristics. Accent comes into play. The rate of speech. Some people speak faster, some people speak slower, loud, soft. Your age also changes your characteristic of your speech. The child speech is going to be very different from adult speech. Various characteristics of speakers also contribute to making a challenging problem. And you might also have language constraints, so maybe you're trying to recognize speech in the language which does not have a written form. As many conversations, that many variation. Natural language processing. Natural language understanding is one of the most important subfields of AI. Formal language theory and phrase structure grammars are useful tools for dealing with some aspects of natural language. The probabilistic context-free grammar formalism is widely used. Machine translation and speech recognition are two of the big successes of natural language technology. One reason that the models perform well is that large and structured sets of text are available. Both translation and speech are tasks that are performed by people every day. On the other hand, tasks like parsing sentences have been less successful in part because no large corpora of parsed sentences is available. NLP algorithms are typically based on machine learning algorithms. Instead of hand coding large sets of rules, NLP relies on machine learning from vastly available text. Advances in natural language processing is working along the lines of certain new vectors. Automatic summarization calculates the frequencies of words, then sorts, simplifies, and reconfigures a body of text based on the most meaningful parts of a context to bring out the summary. Sentiment analysis takes the way in which humans express opinions with language and refines it into more concise and focused structure with clear meaning. Sentiment analysis, a way to identify and categorize opinions expressed in a piece of text, especially in order to determine whether the writer's attitude towards a particular topic or product is positive, negative, or neutral. Question and answer is, of course, the explicit and ultimate priority in addressing a query, employed to funnel all searches into the one common, topical, and correct response that most users are seeking. Let us touch upon few algorithms used for NLP. Summarizer algorithm extracts the most important and central ideas while ignoring irrelevant information. You can use Summarizer to automatically summarize a block of text, exacting topic sentences and ignoring the rest. Parsi McParsyface is a language parsing deep learning model that is made by Google that uses point of search tagging. Parsi McParsyface is a language parsing deep learning model that is made by Google that uses point of speech tagging. You can create chatbots with the help of the algorithm. AutoTag that automatically generates keyword tags from content, a technique that discovers topics contained within a body of text. You can use the algorithm to generate keyword topic tags from a document, like how your Google Mail tags mails. Named entity recognition. Algorithm identifies the type of entity extracted, whether it is a person or place or any kind of entity. Porter Stemmer is an algorithm that reduces words to their root. There are a number of open source NLP libraries if you want to give it a try. Apache Open NLP, a machine learning toolkit that provides tokenizers, sentence segmentation, part of speech tagging, named entity extraction, chunking, parsing, coherence resolution, etc. Natural Language Toolkit (NLTK), a Python library that provides modules for processing text, classifying, tokenizing, stemming, tagging, parsing, etc. Stanford NLP, a suite of NLP tools that provides similar tools as NLTK. Mallet, a Java package that provides NLP tools. Now let's look at different kinds of robotics. Robots are physical agents that perform robo tasks by manipulating the physical world. To do so, they are equipped with effectors such as legs, wheels, joints, and grippers. Effectors have a single purpose: to assert physical forces on the environment. Robots are also equipped with sensors, which allow them to perceive their environment. Present-day robotics employs a diverse set of sensors, including cameras and lasers, to measure the environment, and gyroscopes and accelerometers to measure the robot's own motion. Most of today's robots fall into one of three primary categories. Manipulators or robo-arms are physically anchored to their workplace, for example, in a factory assembly line or on the International Space Station. Manipulator motion usually involves a chain of controllable joints, enabling such robots to replace or place their effectors in any position within the workplace. Manipulators are by far the most common type of industrial robots. Some manipulators are used in hospitals to assist surgeons. Car manufacturers use robotic manipulators. The second category is the mobile robo. Mobile robots move about their environment using wheels, legs, or similar mechanisms. They have been put to use delivering food in hospitals, moving containers at loading docks, and similar tasks. I'm sure everyone knows unmanned group vehicles that drive autonomously on streets, highways, and off-road. The Planetary rover explored Mars for a period of 3 months in 1997. Subsequent NASA robots include the Twin Mars Exploration Rover. Other types of mobile robots, UAV, include unmanned air vehicles, commonly used for surveillance, crop spraying, and military operations. Autonomous underwater vehicles are used in deep sea exploration. Mobile robots deliver packages in the workplace and vacuum the floors at home. The third type of robo combines mobility with manipulation and is often called as mobile manipulator. Mobile manipulators can apply their effectors further afield than anchored manipulators can, but their task is made harder because they don't have the rigidity that the anchor provides. The field of robotics also includes prosthetic devices, artificial limbs, ears, and eyes for humans, intelligent environments, such as an entire house that is equipped with sensors and effectors, and multi body system, wherein robotic action is achieved through swarms of small cooperating robots. Practical robotic systems need to embody prior knowledge about the robo, its physical environment, and the task that the robo will perform so that the robo can quickly learn and perform safely. The challenges in this field are that it might take years to run trials. Furthermore, real crashes really hurt, unlike simulated ones. Supervised learning and unsupervised learning are the buzzwords that you will mostly hear when it comes to machine learning. Supervised learning, as we understood in previous part of the video, is implemented when you know the goal. Prediction methods are commonly referred to as supervised learning. Supervised methods are thought to attempt the discovery of the relationships between input attributes and a target attribute. A training set is given and the objective is to form a description that can be used to predict unseen examples. Say, for example, there is a fish packaging organization. The machine should be able to identify the kind of fish and label it. To do so, the machine has to be first fed with the features of the fish, height, weight, eye positions, name, and lots of other attributes. Unusually, when you interact with a system, you give input to the code and you get an output. In AI, ML, and especially supervised learning, you give output first and then data to the system based on which you derive a code and then use the code to learn and give you output over a period of time. To achieve this, you will have to build a predictive profile of the historical outcome using a collection of potential input fields, and then explore all combinations, interactions, and contingencies. The resultant profiles will be used to understand and predict future cases. The usual problems that these learning algorithms resolve are classification. The program assigns a class to a given record of attributes. Say you give a picture to the system. Based on number of algorithms, the system will decide whether the system is a dog or a cat. Or provide loads of historical data about different loan availers in the bank and ask the system to predict the default probability of a customer. Regression. The target attribute is formed by infinite values and you have to fit a model to learn the output target attribute as a function of input attributes. Time series analysis. Making predictions in time. The test process for supervised learning is interesting. The data, that is observations, measurements, etc., are labeled with predefined classes. The software will learn a model using the training data, and the model will be tested using unseen test data to assess the model accuracy. Unsupervised learning. In unsupervised learning, the system will be given a set of data, and the task is to establish the existence of classes or clusters in the data. There is no supervisor, and only input data is available to the system. The aim is now to find regularities, irregularities, relationships, similarities, and associations in the input. The usual problems that unsupervised learning resolves are clustering. Clustering is the process of grouping similar entities together. The goal of this unsupervised machine learning technique is to find similarities in the data point and group similar data points together. Bringing out association rules. Association rule learning is a rule-based machine learning method for discovering interesting relations between variables in large databases. It is intended to identify strong rules in database. For example, in real supermarket scenario, these are the popular association that was found. The most popular transaction was of pip and tropical fruits. Another popular transaction was of onions and other vegetables. If someone buys meat spreads, he is likely to have bought yogurt as well. Relatively many people buy sausage along with sliced cheese. Outlier detection, a process of finding data examples with behaviors that are very different from the expectation. Anomaly detection and outlier detection that are used during the data understanding and data pre-processing stages. Anomaly detection is also a task on its own. Anomaly detection finds extensive use in a wide variety of applications, such as fraud detection for credit cards, insurance, or healthcare, intrusion detection for cybersecurity, fault detection in safety critical systems, and military surveillance for enemy activity. Tools, software, and techniques. I'm pretty sure you'd like to jump into AI bandwagon. Here are the top languages that are most commonly used for making AI projects. Python. Python is considered to be in the first place in the list of all AI development languages due to the simplicity. The syntaxes belonging to Python are very simple and can be easily learned. Therefore, many AI algorithms can be easily implemented in it. Python takes short development time in comparison to other languages like Java, C++, or Ruby. Python supports object oriented, functional, as well as procedure oriented styles of programming. There are plenty of libraries in Python which makes tasks of the developer easier. For example, NumPy is a library for Python that helps us to solve many scientific computations. PyBrain is used for machine learning in Python. R. R is one of the most effective languages and environment for analyzing and manipulating the data for statistical purposes. Using R, we can easily produce well-designed publication quality plot, including mathematical symbols and formulae where needed. Apart from being a general purpose language, R has numerous of packages like RODBC, Gmodels, class, and TM, which are used in the field of machine learning. These packages make the implementation of machine learning algorithms easy for cracking the business associated problems. Lisp. Lisp is one of the oldest and the most suited languages for the development in AI. It was invented by John McCarthy, the father of artificial intelligence, in 1958. It has the capability of processing the symbolic information effectively. It is also known for its excellent prototyping capabilities and easy dynamic creation of new objects with automatic garbage collection. Its development cycle allows interactive evaluation of expressions and recompilation of functions or file while the program is still running. Over the years, due to advancement, many of these features have migrated into many other languages, thereby affecting the uniqueness of Lisp. Prolog. This language stays alongside Lisp when we talk about development in AI field. The features provided by it include efficient pattern matching, tree-based data structuring, and automatic backtracking. All of these features provide a surprisingly powerful and flexible programming framework. Prolog is widely used for working on medical projects and also for designing expert AI systems. The good friend Java. Java can also be considered as a good choice for AI development. AI has a lot to do with search algorithms, artificial neural networks, and genetic programming. Java provides many benefits: easy use, debugging ease, package services, simplified work with large scale projects, graphical representation of data, and better use interaction. It also has the incorporation of Swing and SWT, the standard widget toolkit. These tools make graphics and interfaces look appealing and sophisticated. MATLAB. MATLAB is where you can use image processing. A large portion of machine learning and modeling is done in MATLAB for research and proof of concept and C++. If you're looking forward to learn fully developed tools or platforms, here you go. Hailing from the Google family, TensorFlow proves to be a robust open source framework that supports deep learning and which can be accessed even from a mobile device. TensorFlow is considered an apt tool for statistic program development. As it offers distributed training, machine models can be trained a lot more effectively at any level of abstraction that the user prefers. Features: a scalable multi-programming interface for easy programming. Pros: the language used by TensorFlow is Python, which is very popular nowadays. This framework is capable of high computational power. Hence, it can be used on any CPU or GPU. Uses computational graph abstraction to create machine models. Cons: to make a decision or prediction, the framework passes the input data through multiple nodes. This can be time consuming. It also lacks many of the pre-trained models of AI. Microsoft CNTK is a faster and versatile open source framework that is based on neural networks which support text, message, and voice remodeling. It provides an efficient scaling environment due to a faster overall evaluation of the machine models while taking care of accuracy. Microsoft CNTK has integrations with major massive datasets, making it the leading choice to be adopted by big players like Skype, Cortana, etc., with a very expressive, easy to use architecture as well. Features: highly optimized to provide efficiency, scalability, speed, and high level integrations. Has built in components such as hyperparameter tuning, supervised learning models, reinforcement, CNN, RNN, etc. Resources are utilized to provide the best efficiency. Own networks that can be expressed efficiently, such as full APIs, both high level and low level. Pros: as it supports Python and C++, this framework can work with multiple servers at once and hence makes the learning process quicker. It has been developed keeping in mind about the recent developments in the world of AI. Microsoft CNTK's architecture supports GAN, RNN, CNN. It permits distributed training to train machine models effectively. Cons: it lacks a visualization mode and mobile ARM support. Caffe 2. Caffe is a deep learning network that comes along with the preloaded set of trained neural networks. This should be your first pick if your deadline is close. Known for its image processing capabilities, this framework also had extended support of MATLAB. Features: all of its models are written in plain text schemes, offers massive speed and highly efficient work since it is already preloaded, an active open source community for discussion and collaborative code. Pros: interlinking C, C++, and Python. It also supports the modeling of CNN. Efficient when computing numerical tasks due to its speed. Cons: Caffe is not capable of handling complex data but is comparatively fast while handling visual processing of images. Amazon Machine Learning. Trending in AI community, Amazon Machine Learning offers high-end support in the development of self-learning tools. This framework already has existing user bases in its multiple services like AWS, S3, and Amazon Redshift. This is a managed service by Amazon with three operations performed on the model, which are data analysis, training of model, and evaluation. Features: there are tailored tools for every level of experience in the AWS, even if you are a beginner, data scientist, or developer. Security is of utmost importance, so all data is encrypted. Provides extensive tools for data analysis and comprehension. Integrations with all major datasets. Pros: you don't need to write a lot of code with this framework. Instead, it lets you interact with AI-powered framework via APIs. Commonly used by data scientists, developers, and ML researchers. The entire framework is abstracted, so if you'd like to choose a particular normalization or machine learning algorithm, you can't. It also lacks data visualization. Apache Mahout. Apache Mahout, being an open source framework, aims at the development of scalable machine learning frameworks. It doesn't deal with APIs as such, but helps in the implementation of new machine learning algorithms by data scientists and engineers. Features: known for its scalar DSL, which is mathematically very expressive, extends support to multiple backends which are distributed. Pros: it aids in clustering, collaborative filtering, and classification. Its computational operations make use of Java libraries, which is faster. Cons: Python libraries are not as compatible as Java libraries with this framework. Computational operations are slower than SparkMLib. SparkMLib. SparkMLib framework by Apache is supported by R, Scala, Java, and Python. It can be loaded with Hadoop workflows for providing machine learning algorithms such as classification, regression, and clustering. Features: apart from Hadoop, it can also be integrated with the cloud, Apache, or even standalone systems. High performance is one of the key elements and is said to be 100 times faster than MapReduce. Spark is exceptionally versatile and runs in multiple computing environments. Pros: it can process vast amounts of data quickly as it works on iterative computation. It is available in many languages and easily pluggable. It cycles large scales of data processing with ease. Cons: it can be plugged with Hadoop only. It is difficult to understand this framework's mechanism without extensive work on the same. There are a few more. It doesn't take much time to learn a programming language or a tool. What is needed is a deeper knowledge of various techniques, algorithms, theories, and an understanding of how and where to apply. For such an understanding of artificial intelligence and machine learning, you might need 150 to 180 hours. Thank you for learning with Blackbuck. Hope you have learned a bit of AI with the help of the video. Blackbuck Engineers Private Limited brings out best of both world of education and training. We are partnering as preferred partners for providing executive education to Government of Telangana. Our syllabus is NASCOM and HICIA verified, and you get a formal post-graduation from university-led UGC certified programs. Take the right step. It matters most for Industry 4. Happy learning.